Here we'd like to show that y of x equal to 1 over x is a solution of the nonlinear first-order differential equation y prime plus y squared equals 0. So this isn't too bad at all. Let's go ahead and just plug it in and see if it satisfies it. So what do we need? Well, we need the first derivative. So what would y prime be here? Well, the supposed solution is 1 over x, which is x to the negative first power. So the derivative would be negative 1 over x squared. Okay? And so now let's go ahead and plug in. What would we have? Y prime plus y squared is equal to, well, we just calculated y prime, negative 1 over x squared, plus y. What's y? It's 1 over x quantity squared, and it's pretty clear that that's equal to 0. So it satisfies the differential equation. So now on any interval where y is continuous, we have found a solution. So in particular, y of x equal to 1 over x is a solution on the interval, I guess, negative infinity to 0, and also on the interval 0 to infinity. Because remember, our solutions need to be continuous. So the real heart of this problem is showing that this guy right here, y twiddle, is in fact not a solution of this differential equation. And at first glance, this seems to fly in the face of a theorem, the theorem of superposition that we saw, saying, hey, if you have a solution, or two solutions, any linear combination of those two solutions is also a solution. But we have to be careful. Let's recall the principle of superposition. What's it say? It says that if y1 and y2 are two solutions of a homogeneous, and here's the key thing, linear equation, then any linear combination, say y of x, equal to, say, c1 y1 of x plus c2 y2 of x is also a solution. So notice the key idea, it has to be linear. So all bets are off if we don't have a linear equation, and notice we don't have a linear equation. We have a y squared in there. So the last bit to this problem is let's just show that our y twiddle over here doesn't solve the equation. So let's come down here. So what are we going to need? Well, what's the equation? Y prime plus y squared equal to 0. What's our supposed solution? We called it y twiddle of x equal to c over x. And we're making sure c isn't 0 or 1. And so let's plug this in and see if it works. So we need the derivative. So y twiddle prime of x is going to equal what? It's going to equal negative c over x squared. And so let's just see what the left-hand side is doing here. So we have y twiddle prime plus y squared, y twiddle squared, is equal to y twiddle prime, we just found is negative c over x squared, plus y twiddle squared, so that's c over x quantity squared. And so what are we going to get? Well, we'll get negative c over x squared plus c squared over x squared. We can simplify that to be c squared minus c over x squared. And in order to have a solution, we would need this to equal 0, right? That's what we'd require to have a solution. But what's that going to tell us? The only way for that to happen is if c squared minus c equals 0, which c times c minus 1 equals 0, which implies that c would have to equal 0, or c would have to equal 1. And that's precisely what we said c wasn't allowed to be. So any other choice of c would mean y twiddle is not a solution. So what's the point? The point is when applying our theorems, in particular our theorem of superposition, we can't ignore any words, right? We need to absolutely read the whole thing. We need homogeneous and linear in order to apply the theorem.